Hi, I am Alper Yazar. Welcome to the fourth part of the video series about my ISE-USB RS422 project. In this video, I will demonstrate the driver installation, programming, and functional test of an ISE-USB RS422 board. Enjoy the video. Okay, what we see here is the virtual machine that we left in the second part. It's Windows XP Service Pack 3, and we will use this virtual machine. And at the top left corner, approximately I think in this area, you will see the board itself. It's the board with serial number 2, and as you can see there is a USB cable, and we will connect this board to this virtual machine, and we will see the status of LEDs and the screen of the virtual machine together. Okay, we are ready. Let's connect our board to computer and see what will we get. The other end of this USB cable is connected to PC already. Now let me connect to this side. Connect this side to the board, and okay. It turns around middle. Okay. Okay, good. Did you notice a pulse on this RX LED? You should notice. As I mentioned in the previous video, in the third video, we didn't program the device, and this LED glows when the device is in the sleep mode. So when we plug this board to the computer, it's in the sleep state initially, and once the operating system do some jobs, enumerate the device, it wakes up, and the LED doesn't glow, and this device is now active now. And let me connect the board to my virtual machine from my real computer. So attach my device. Okay. So the virtual machine asks a driver for this device. At this time, let's click cancel and see it from the device manager. Okay, device manager. We have a question mark. It's not properly installed at this time. So let's get back to our project folder. Remember that we download it from the GitHub page in the second part 2 video, and let's open this folder again. So let's open driver folder, Windows, and install this driver. Okay, extract. Next. You should read it always. No, I'm kidding. Continue anyway. Okay. Okay. Found new hardware. Good. No, not this time. Oh, okay. It's done. Finish. And check device manager again. And we have a new COM port. It's a serial port. And we are done. But remember that this board doesn't isn't working like a converter board now. We have to program it. So let's get back to the utility folder and install the FTproc. This is a software from the USB chip vendor, FTDI. We have to install it to program the board. Okay, next. Do you agree? Yes, I do. Okay, 3.3 megabyte. Install everything. Okay, fine. Okay. We have a new icon here. Let's click this. Oh, it's not running. Again, not running. So let me solve the problem first. I did a quick search on the internet and I found that we have to install a Net Framework 4.0 from Microsoft to run FTproc. Okay, I install it and shall we try together? Is it working now? I hope, and yes, it's working. Okay, and this is FTproc. We will use it to program our board. So device, scan and parse. Oh, it's found our connected board with default configuration. So we want to program this device. As I mentioned in the first video, there are 4 different operation modes, and we have 3 different working configuration files. So right click our device, apply template from file, not my documents, file from the GitHub, firmware, and we have 4 configuration files. This default is the default setting, and this settings actually. And we are not going to use it. It's not this will not work as converter board. Let's start with test our board with RS4 22 configuration. We select it and open and successfully applied. Okay, and okay, new description, for example. Let's program it. Program device. Okay, we have new serial number. We have to connect and disconnect we have to disconnect first, of course, and connect device. So we are done with FTproc. Let me close it. First, let me unplug virtually from my virtual machine. So I disconnect our board from virtual machine. And now from the USB port, Okay, it is connected. And let me connect again, and we should not see the a short pulse on this RX LED, because now it works as a real receive LED. This LED glows when we receive data from the bus, not indicates the sleep mode now. Okay. Did we see a short pulse? Okay, this may be due to the some transients on receive bus, maybe. Okay, you'll investigate it. Maybe it acts like receiving a short data at first block. Okay, let me connect again. Okay, we have an ISO USB RS422 version 1 board in RS422 mode. It's great. Okay, let me connect it. My real computer is doing some stuff. Trying to transfer this device to the virtual machine. It's installing something, I hope. It's running. You cannot see my real computer, but it's doing something now. Driver installation. Okay, hell, what is that? Okay, we are waiting my real computer. Oh, good. And okay. Windows Update search for software. No, not this time. Recommended, yes. We have already this driver. We install it. Continue anyway. Okay. USB serial converter. And okay. No COM port. No, not this time. Recommended. Continue anyway. Finish. And we have now new COM port. COM4. Okay. Great. It's new. It's the new serial number. My initials and a random generated number. I don't know what can we see here. Some USB related thing. Okay. Now we are ready to test and verify our board. So let me do a quick loopback connection to test this board. And before making the loopback test, we can test the only transmit side without any connection actually, and we will observe the TX LED, this LED. Okay, let me open the famous serial port client terminal in Windows XP. Hyperterminal. Okay. You recommend that your default. No, I don't want it. Okay, no dial-up. I don't need a dial-up modem. Yes, I want to cancel. Okay. Okay. Name test. Cancel. Yes, I want to cancel. Okay. And comfort. Yes. Is it comfort? Actually, I don't have any other comforts. But let me briefly show you. Okay. Properties. Hardware. If you have COM1, it's generally is the COM port of your motherboard, the actual COM port on your computer, not a USB converted. It's a general rule. Okay, COM4, single. Okay, COM4, okay. What is our baud rate? I don't care. This board supports up to 3 megabit per second and all of them are supported now. And let's choose this one randomly. Flow control, I don't care actually, but select none. And we are connected to the board, and local echo is closed, disabled now. Is this okay? This is unchecked. Echo type characters locally, and we don't see. We will see only received characters on the screen. And now I'm going to press some keys on my keyboard randomly. Okay. Okay. Do you see that? We are transmitting some data to bus, to RS422 bus. Unfortunately, we don't have any listener. We are alone now. And press randomly. Even if a single character, it shows the transmission. Okay, let me change the baud rate and select the slowest one. Okay, this is not supported. Start with 300 bits per second. Apply. Okay. Connect. And random keys works perfectly. Okay, let's do the loopback test and test the receive side. Okay. I did a loopback connection. What's the loopback connection? It's very simple. The idea behind the loopback connection is that we want to listen what we transmit. That's all. So this is transmit side, positive and negative, and this is receive side, positive and negative. Then I connect positive transmit to the positive receive, and similarly I connect the negative transmit to the negative receive. So we are listening what we are transmitting now. And let's go back to our hyperterminal screen. Remember that local echo is disabled now. We will see what we receive, not what we transmit. So I press keys randomly, and here we go. Let me, okay, ISO USB RS422 serial number 2. First, loop back test. It is working. And I am pressing random again, and you are seeing the both LEDs are glowing now. Transmit and receive at the same time. So this verifies that our board is actually working. But you can use another verification tool. It seems to be more realistic, maybe, or more detailed way to test the board. I'm going to show this tool. Close the hyperterminal. Okay, let's go back to our folder and go to the utility folder, and we have WinSSD software. Okay, it's a testing tool. Let me show step by step. We are using COM4, and I select 4. Click open. Okay, port is open. Now settings. You may want to set the highest baud rate available to see the limits of the board, maybe. Okay, that's fine. You can do some loopback tests. Okay, let me click start, and please observe the LEDs. Okay, and loopback works good. Also, you may test bit error rate if you have any. Reset stats. No, test time is running again. Okay, start again and press start. No data. Stop. It's not working good. It's transmitting but receiving nothing. Maybe there's a problem with the virtual machine. The IO operation. What is this? How can I see the... Oh, no, not this. Oh, I think there's a problem with the virtual machine. Okay, lower the baud rate. For example, let's select this. Okay, bit error rate. Ah, it's working now. For low baud rates, okay, it's sending a pattern, I think, and it shows the actual transmission and receive baud rate. Okay, let's stop. Okay, increase the baud rate again. Select apply. Let's start it again. Loopback test is working without any problem, but Okay, I'm going to test this on my real computer now, and I will show the results. I don't think there is a problem with the board itself, but this virtual structure may cause some problems. Okay, and let me go back to my virtual, sorry, my real computer to uh, test the board with this baud rate value. Okay. Now I am on my real computer and same software Win SSD. Sorry for the local capture. I am captured to this software only. Okay, this device is connected to COM21 and this computer. And similarly, let's open the device and let's go to settings. Sorry that this is Turkish now, but not so important. And select the same, the highest baud rate, same settings, and press OK. So first do the loopback test. It's working. It was working in the XP too. And let's do the critical bit error rate test. So to reset the test time, I go back and click this tab again and click start. So now it's working, as you can see. And the real bit baud rate is close to the actual baud rate. Okay, it's a ripple on this baud rate, but I think it's related with the software. If you stop the test and up to record the stop time, and if you divide this rate total bytes to this time, you can find the actual rate, and it is quite close to the actual baud rate. Okay, don't trust your virtual computer very much. It's not very a good test environment actually. Okay, so I want to show another scenario. Let's open our port and select the lowest possible baud rate in this software. But remember that 110 bit per second are not supported by this hardware. The minimum support value is 300 actually, and let's see what will we get. Okay, I select baud rate and I will do bit error rate test only. Okay, let's reset stats. It's working. It seems to be working, but the baud rate is not correct. LEDs are glowing. Looks fine, but the baud rate isn't correct. So it cannot provide 110 bit per second. So stop this and test the lowest correct baud rate. In settings, 300, and let's apply the settings. Okay. Notice that each frame size is about 500 bits, and with this baud rate it's taking very long times to transmit, even if a single frame. Actually, we transmit one frame. Okay, receive one, and it's not correct calculating the bit. Sorry, baud rate value is so low. Okay, no data. It's not doing this, but it's working. It should work. WinSSD isn't able to do this calculation. Okay, that's all. We verify our board. I press stop, but it's counting now. Also, okay, our board is now working, and we are happy makers. So in the next video, I will talk about the other modes, RS485 modes, and we are going to communicate two different RS420 ISO-USB RS422 boards with using different configurations and bus topologies, and with different cables. Not different cables, but cables with different lengths. So, see you.